if we consider this group work problem, we're going to learn how to get the components of these vectors and how to add these vectors algebraically, okay, in this part. So we're going to do two things now. Let's read the question again. Suppose you first walk 12 meters in a direction 20 degrees north, west of north. So as soon as you begin to read these words, you want to draw your axes and your north, south, east, west. So here's my origin, okay. I think I need to change this. So here's my origin, and this is going to be my positive x direction, and this is going to be my positive y direction, okay? Which means this is north, this is south, this is east, and this is west. So suppose you first walk 12 meters in the direction 20 degrees west of north. You're at the north, you need to go 20 degrees towards the west. Let's say this is my 20 degrees. And this is my first direction. Okay, I need to write an A. And this angle is 20 degrees. It's hard to... Right, so this angle here is 20, okay, and let's call this vector A, the first motion, first direction in which we walk, okay. Then 20 meters in a direction 40 degrees south of west. So this was 12 units, yeah? I'm just going to write the 12 here. 20 meters in a direction 40 degrees south of west. So I'm west, I need to go 40 degrees south of it. Something like this, you need to draw a straight line. And this angle here is my 40 degrees south of west. Yeah? And this line should be a little longer since it needs to be longer than the other one. And this is 20 units, 20 meters. Yeah? What is the compass direction of the line connecting your starting point to your final position? So if I was doing graphical addition, I would take my vector B, let's mark this as vector B, and pick it up, put it top, tip to tail, over here. So I expect my resultant vector to be generally towards the left, okay? It might just be to the north of west or just to the south of west. Somewhere in there is going to be my resultant, a low value just north or just south of the west. So I know I'm going to have to add that 180 degrees at the end, yeah? Okay, so now that we have our two vectors, A and B, let's find the components, okay? So I'm going to do that. I don't know how to stop this thing. Okay, so here's the same diagram, okay? But vector A is here at 20 degrees, vector B is here at 40 degrees. We're now going to get the components of vector A, and we're going to get the components of vector B. Then we're going to add up the x components of both together to get a resultant x component, the y components of AY and BY together to get a resultant y. And then we'll sum those two resultant x and resultant y's using the Pythagorean theorem to get a resultant vector and its direction. Okay, so let me show you. So the resultant vector is going to be the resultant of vector OA plus vector OB, okay? And vector OA is nothing but the sum of the components of this vector, which is vectors OAX and OAY. The O is not essential to say. If you like, you could just call it AX and AY. Looking at this vector, you can see that its x component is going to be negative because the projection is going to come to the left of the origin, and its y component is going to be positive. Okay, so what's the formula we need to use? We have ax is going to be a cosine of the angle with the positive x direction. So we need this entire angle here from the positive x direction. Oops. And that angle is 90 plus 20, so that's 110. So we have 12 cosine 110. Remember, a cosine theta, yeah, is going to give me ax. Or if you put this into your calculator, that's going to give you negative 4.1, which seems reasonable since we expected it to be a negative number. Similarly, ay is going to be a sine theta, sine of the same 110 degrees. Okay, a is 12 units, so 12 sine 110, which comes out to be 11.2. Okay. All these are in meters since the 12 was in meters. So we got our two components for the A vector. Similarly, we need the x and y components for our B vector. You want to think out, do you expect this to be a negative or positive value, the bx and by? So I would think that bx would be negative since its projection is again going to be to the left of the origin, and by is also going to be negative since it's going to be below the origin, right? So if you work out bx, and let me just see if I can clear the screen for you, just a second. So let's go back. Let's, we want to undo, erase. So that we can actually look at the sheet of paper. Perfect. Okay, thank you. And now we can read much better. So bx is going to be b cosine theta, where theta is this angle all the way from the x direction all the way to the vector b going counterclockwise. So that's 180 plus 40 is going to be 220. So I have b cosine 220. B is 20 units. So 20 cosine 220, which comes out to be negative 15.32. Similarly, by is 20 sine 220 degrees, which comes out to be negative 12.86. So now I have my two x components, one from each vector, my two y components, and I'm just going to arithmetically add them. Okay, since they're both in the same direction, they can just be along positive or negative of the x-axis, positive or negative of the y-axis. So we can algebraically add them. So take ax, negative 4.1, and add it to bx, negative 15 point something. So we're going to get negative 19 point something. Yeah? There we go. Negative and negative makes negative 19.424. And this is going to give me my resultant Rx. Similarly, now in the y direction, 11.27576. I need to add it to negative 12 point something. It's going to give me a small negative number. What do we get here? 11.276 and negative 12.86 gives me negative 1.5. So this is my resultant y component. So now I have a resultant x component and a resultant y component. I can find the magnitude and the direction. Let's look at the direction. The direction is going to be given by tan inverse of the y component, which is this, negative 1.5, divided by the x component, which is negative 19.4. And when you put this into your calculator, you're going to get an angle of 4.6. Remember, this is going to be towards the right of the y-axis. So we were not expecting a result along the right? We are expecting a result in this second or third quadrant. Yeah? So we need to add 180 degrees to this. And we're going to get 184.6. So let's look at our result here now. Okay, this is much more neatly written out. This is our same x component, resultant x component, resultant y component. Okay, and we were doing this, yeah? So they wrote it as 4.6 degrees south of west, which is, it's 4.6 degrees over here. You add 180 to it, you get 180 to going south, 4.6 south of west, or 184.65 from the x-axis. Huh? And what's the magnitude? The magnitude is going to be given by this Pythagorean theorem, so square root of rx squared plus ry squared, which is going to give me 19.5 meters. So this is the magnitude of my resultant vector here. And the direction, which is this angle theta, is given by, I would write it more as 184.65. So we write from the positive x direction.